So this is lesson 37A in Algebra 2, Chemical Compounds and Parallelograms, and I call it A because even though the lesson is a little short, it is going to take some time to get through the chemical compound part of this lesson because we have to go and talk about chemistry a little bit. Okay, first of all, what we've got is we've got atoms. Atoms, we have a hydrogen atom, oxygen atom, chlorine atom, sodium atom, all these different pieces that you've had in science. We've also got a molecule, and a molecule is a mixture of several different atoms that form a substance. So in this case, H2O is water, and this number 2 here tells you how many hydrogen atoms it takes, and that's an assumed 1 there, how many oxygen atoms that takes. So we have a total of 3 atoms that make up water, H2O. All right, and the one thing that's important, and that's what this lesson is pretty much going on, is that each atom and each molecule has a weight. So if we are looking at the weight of an atom, we call it the gram atomic weight. You can read my writing, that is a C. And if we're looking at the weight of a molecule, we call that gram molecular. Sorry about my writing here, guys. Gram atomic weight is the weight of an atom. Gram molecular weight is the weight of a molecule, like, again, H2O, or this is table salt, sodium chloride, NaCl. So each of those weighs something, and that's what we're going to look at. So make sure you know the difference between a gram atomic weight, the weight of an atom, and gram molecular weight, which is the weight of a compound or a substance of more than one atom. All right, so that's what we're going to look at. And in the book, it will tell you how much these things weigh. Over the years, you might get some of them memorized, but for the most part, they're going to tell you. So if you look at example 37.1, it says the chemical formula for water is H2O. And they're saying we have 3,600 grams of water. Okay, so when we take our container of water, we have 3,600 grams. And what we want to figure out is how much of this 3,600 grams, how much of that weight is oxygen, and how much that weight is hydrogen. And this particular example, it says if we have 3,600 grams of water, what is the weight of the oxygen? So all we're concerned about is how much the oxygen weighs of this 3,600. So if we were to divide that out, how much of that 3,600 is oxygen? Well, they tell us that oxygen, which the letter O is the symbol for oxygen, weighs 16. And they also tell me that hydrogen weighs 1. Okay, and we're going to call that grams. We'll give it a unit because that's gram atomic weight. It's going to end in grams. Okay, so what we're going to do here is we're going to make a ratio. We are comparing how many grams of oxygen are in H2O, and then we're going to find out how many grams of oxygen is in 3,600 grams. So if we can find out how much oxygen weighs, which we found out is 16, and how much one, I don't even know what you would call it, one molecule of water, I guess is what we would call it. We can find out how much oxygen is in one molecule of water. We can find out how much oxygen is in this because it's going to be ratios. So I know oxygen is 16. Well, how much does water weigh? Well, we have one bit of oxygen, and that's 16, and we have 2 hydrogens. So we not only have 1 gram, but we also have a second gram, so we have 2. So the combination of all 3 of those means that we have 18 grams. So 18 grams of water and 16 grams of that is oxygen. So that's the ratio. And I can put my total weight of water down here, and what I'm looking for is X grams of oxygen. Make that oxygen so it doesn't look like a 0. Now we just cross multiply, and we get 18 times X equals 16 times 3600. And then we divide through, and we can find out exactly then how much the oxygen in that 3600 grams weighs. And when we do the math, we find out that X equals, or the number of grams, is 3200 grams. So there are 3200 grams of oxygen in that 3600 grams of water, which means there are 400 grams of hydrogen. But that's not what they're asking, so we just found the oxygen, and that's good. All right, let's look at example 37.2 in our next video.